Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydel online class. Today we want to talk about another application of differential calculus. That is another application of differentiation, and it's called increasing and decreasing function. So if it's called increasing and decreasing function, if f of x is an increasing function at a given interval, then the y dx will be greater than 0. That is, if y, which is f of x, of course, if you check my videos on differentiation, we know that f of x, y is a function of x, so y is f of x. So if y, which is a function of x, is an increasing function, dy dx, it is an increasing function at an interval, dy dx is greater than 0. And if y, which is equal to function of x, is a decreasing function, so if it's a decreasing function, dy dx will be less than 0. That is, this is increasing. This is when we have increasing function, and this is where we have decreasing, function. So if you have a function at a given interval, then dy dx, the derivative of that function, when it's greater than 0, when it is positive, is called an increasing function, and when it is less than 0, that's when it is negative, it's called a decreasing function. So we are going to take two examples to be able to differentiate between these two functions. Let's take the first example. Example 1, where we have find the range of values of x for which each of the following is increasing. The first one is where we have y to be equal to x squared minus 4x plus 3. Then the second one is where we have 8x plus x squared minus 8x cubed all over 3 equal to 0. So what do we do here? Of course, if we are to do the first one, we say y is x squared minus 4x plus 3. So if this function is increasing, we know that the first derivative, dy dx, will be greater than 0. So in this case now, when we differentiate this, we are going to have 2x minus 4. 2x minus 4. We have to find the range of values of x for which this function is increasing. Because this function is increasing, the y dx will be greater than 0. Then here we have 2x greater than 4. By the time minus 4 crosses the equality, that inequality sign, it changes to plus. Then we divide both sides by 2. At the end of the day, we have x to be greater than 2. X to be greater than 2. So that is the value of x for which this first question that we have here is increasing. So we go ahead, we go to the second question. Let's go to the second question under example 1b, where we have y to be equal to 8x plus x squared minus x cubed all over 3. So that is the second example. We want to find the value of x for which this function is increasing. So if I differentiate dy dx, it will be equal to, when I differentiate this, I'm going to get 8 plus 2x. Then by the time I differentiate this, 3 will come down minus 2. I'm going to have minus x squared greater than 0. That's what I'm going to have. Then what I have at the left hand side, is a quadratic. So is a quadratic expression. I can go ahead and factorize this. That is here. I'm going to get 8. This will give us plus 4x minus 2x minus x squared greater than 0. Then I do the grouping. What is common in this first one? What is common in the first one? What is common in this first one is I have, if I bring out 4 here, I'm going to have 2 plus x. Then here, if I bring out minus x, here, I'm going to have 2 plus x also greater than 0. And of course, when we factorize, what we have in the first bracket must be what we have in the second bracket. So I'll combine these two. I'm going to have 4 minus x into bracket 2 plus x greater than 0. That's what I'm going to have. That's what I'm going to have. Then I can actually continue from there. So I have 4 minus x greater than 0 or 2 plus x greater than 0. Then in this case, I will have 4 greater than x or 2. Or in this case now, I will have 4 greater than x or x greater than minus 2. That's what I will get there. Then, yeah, I have, if 4 is greater than x, I can rewrite this and say x is less than 4. I can rewrite this and say x is less than 4. Or if x is greater than minus 2, I can say minus 2. I can say minus 2 is less than x. So I can try to rewrite this. If 4 is greater than x from what I have here, or if 4 is greater than x, then automatically x will be less than 4. And in this case now, when I transfer this positive to the other side, I have x to be greater than minus 2. So if x is greater than minus 2, invariably minus 2 will be less than x. Then I can start to combine these two together because I have minus 2. Yeah, I have minus 2. I have minus 2 less than x. That's what I have here. Then I can combine this. This same x is less than 4. I will now say less than 4. That will be the range of value for which that function, for which the range of value of x for which that function is increasing. For that, to that second example. So we take another example, example 2. Let's take another example under decreasing function. Example 2. Let's take another example. Find the range of values of x for which each of the following is this. So in this case now, I'll change it to decreasing. So I'll change this to decreasing. We'll check example on increasing function is decreasing. So that's what you want to do now. That is what we want to do. Excuse me. Okay. For which the function is decreasing. So let's see the function. 2x squared plus 3x plus 1. Then we have x cubed all over 3 plus x squared all over 2 minus 6x. So these are the two functions that we want to find the value of x for which they are decreasing. So the first one, we have y to be equal to 2x squared plus 3x plus 1. If I differentiate this, dy dx will be equal to, if I differentiate this, I'm going to have 4x plus 3. That's the derivative of that. Then under decreasing function, dy dx must be less than 0. And that's what we have. Then 4x will be less than minus 3. So in this case now, we divide both sides by 4. So that x will be less than minus 3 all over 4. So x will be less than minus 3 all over 4. And that will actually be the value of x for which that function is decreasing. So we should take note that if you are dealing with decreasing function, the derivative must be less than 0. Whenever we want to know the value of x for which that function is decreasing, the first derivative must be greater than 0. So we go ahead and take the second example. Let's take the second example. We take the second example where we have y to be equal to x cubed all over 3 plus x squared all over 2 minus 6x. So if I differentiate, take the first derivative under this, I'm going to have x squared. That's what I'm going to get. I will get x squared. 3 can come down here. 3 will cancel 3. Then 2 can also come down here. Plus, that will be plus x minus 6 must be less than 0. That's how to check the value of x for which that function is decreasing. And of course, I'll go ahead and solve the function. So here I'm going to have x squared plus 3x minus 2x minus 6 less than 0. So I do the grouping. So x is common here, I have x plus 3. So minus 2 is common here, I have x plus 3 less than 0. So here I'm going to have x minus 2. I'll combine these two. Then I pick one of the one in the bracket, x plus 3 less than 0. This simply means that x minus 2 less than 0 or x plus 3 less than 0. Then from there, we have x to be less than 2 or we have x to be less than minus 3. And these are the two values. So we now say x is less than minus 3 or x is less than 2 will be the range. So that will be that will be the range of values for which x is decreasing at that particular function. So I would love to stop here because of our time. If you really want to know more about the applications of differential calculus or differentiation, you can check my videos. I have more than 10 videos on differential calculus, differentiation. So just check my videos on differential calculus, differentiation, to actually know more about differentiation. Thank you, and God bless you all.